Hello friends, here in this video we will see a problem on how to calculate the pressure at a point in a pipeline by using differential manometer. So for that we have a problem here. I'll mark this question. A differential manometer is connected at 2 points A and B as shown in figure. The diagram is given. At point B, the air pressure is 9.81 Newton per centimeter square. Find absolute pressure of point A. So this is the question which we have. Based on this question, we have to write the data. Now, here as we see in this diagram, we can see that at A, at B, there are two different pipes, and to that pipes a differential U-tube manometer is connected. On the left hand side, we are having oil whose specific gravity is 0.9. On the right hand side, we have water as well as air. Next, here we have mercury whose specific gravity is given as 13.6. Now, this is the data which we have. Here the question is to find the absolute pressure at point A. It means we have to find the pressure of oil. So here, pressure at point A, this is the question for us. Now, when we have to calculate the pressure at point A, we should know the pressure at point B. Then only we can calculate it. As we see in this question, the air pressure is given. So the pressure of air on the right limb, it is, I'll write down, pressure of air, P suffix air, is equal to 9.81 Newton per centimeter square, or it is 9.81 into 10 raised to 4 Newton per meter square. Now we have to solve this question. So I'll write the solution for this. Since here for differential U-tube manometer, we have to balance or we have to equate both the sides of the differential U-tube manometer. That is, we have to equate the left limb and the right limb. That is pressure equation. So first I'll write down, since total pressure in the left limb is given by, in the left limb, as we can see, here we have oil as well as mercury. So first there is pressure of oil in the pipeline, that I'll indicate it as P suffix A because it is in pipeline A. Next, oil is filled up to 20 centimeter height, as we can see. So because of the 20 centimeter height of oil, there is even pressure exerted by this. So it has to be written. So I'll write down plus rho G into the height of oil which is there. So here I have density of A, that is oil. Next, in the left limb we even have mercury up to 10 centimeters. So even pressure is there because of the mercury column. So it should be written as plus rho G into H. This is for mercury. So I am writing suffix M here. This much is the total pressure in the left hand side. Now I'll calculate the values here. I'll say that therefore this would be PA is what we have to calculate plus rho A. Now since oil specific gravity is given, it is 0.9. So density of oil would be 900 because it is 0.9 multiplied by 1000, that is the density of water. So we can calculate density of oil, that becomes 900 kg per meter cube. So I'll put this value in rho A, 900 into 9.81 multiplied by H. Now H for oil it is 20 centimeters, so in meter it would be 0.2. So here I have into 0.2 plus density of mercury is 13,600 This is a standard value we have to remember. Then 9.81 into height of mercury is up to 10 centimeter, as we can see in the left limb. So that is 0.1 meter. So from this I will get it as PA plus, if I calculate the values here, this would be 13,341.6 plus the value here, it would be 1765.8. So this is the total pressure in the left limb. Here I'll equate it, I'll call this as equation number 1. Now similarly I will calculate the total pressure in the right limb. I'll say that now total pressure in the right limb. Now as we see, in the right limb we have only air and water, no mercury is there. So pressure of air, that is P suffix air, plus the pressure of water. Water is up to a height of 60 centimeter, as we can see from this datum. So this becomes 0.6 meter. So I'll write the pressure exerted by water, that is rho of water into G. Its height is 0.6. So therefore here I'll put the values. Pressure of air is given in the question. It is 9.81 into 10 raised to 4 plus density of water is 1000, we know the value, into 9.81 into 0.6. So from this if I calculate, therefore I'll have the value as, it is 1.04 into 10 raised to 4. This value, I'll keep this as equation number 2. Now once I have equation 1 and 2, I will equate both of them and get the value of pressure at point A. So here I'll say that, therefore equating equations 1 and 2. So therefore here I would be having the value as PA plus 13,341.6 plus 1765.8 is equal to the value on right hand side, 1.04 into 10 raised to 4. Now from this if I calculate, that is I would be shifting these term onto the other side, they would be becoming negative, and my final answer, it comes out to be, it is 88.88 into 10 raised to 3 Newton per meter square. This is my answer. Means this much pressure is there in pipeline A. That is the pressure of oil. So here if we see in this question, they were telling us to calculate, find the absolute pressure at point A. So the absolute pressure at point A is nothing but pressure of oil, and that we have calculated it. The answer is 88.88 into 10 raised to 3 Newton per meter square. So in this video we have seen how to calculate absolute pressure of any liquid by using differential YouTube manometer.